we are going to talk about the graphs of the motion, right? Two types of graphs are there, that is distance versus time graph and velocity versus time graph. Okay, we will try to see how these graphs look like when for different situation. Okay, so at first let us study when the body is static. Can you see the writings on the board clearly?
No.
Throughout the day, this has been the case. Okay, whatever I write on the board, the students are not being able to see. I don't know, maybe some net issue is there, but we cannot actually miss these classes. So I will be lecturing and will try to understand as much as possible. Okay. Is it the case with everyone? Is there anyone who can see it clearly?
Sir, if you take your camera a bit front, then it will be better, I guess,
Huh?
because it's not clear. If you take your camera a bit,
we can see.
আপনার ক্যামেরাটা একটু সামনে নিলে ভালো হয় স্যার। দেখা যায় না
now?
স্যার খুব হালকা দেখা যাচ্ছে।
জি, তারপর
আমার তো একটু কমাই দিলে ভালো হয়।
Okay, so at first we are going to take a look at the condition when the car or anybody or any object that is under experiment is a static. Static means it is not moving. So what will happen? With time, the distance will not increase nor decrease. Okay, it will remain the same. So when the car is static, the distance versus time graph is going to look like this. What about the velocity? When the car is not moving, can you tell me what is the velocity of the car?
Zero.
Zero. That means 1 second, 2 seconds, 3 seconds, the time will approach, but the velocity will not go up than zero. See, along y-axis we have put velocity. If the line goes upwards, that means the velocity is increasing. If the line goes, in the line comes downward, then the velocity is decreasing. So as the velocity is 0, 1 second the velocity is 0, 2 seconds the velocity is 0, so the graph will be along the x-axis. Okay, so this is the first type of graph that we are going to study. Whenever you are given a graph, the velocity versus time graph, and you see that the line is along the x-axis, you have to understand that the velocity is 0, and that is why we can say that the body is static. Now let us take a look when the body is moving. Okay, moving with uniform velocity. Uniform velocity. Now, what does uniform velocity mean? The velocity is changing or not changing?
Not changing.
Very good. The velocity is not changing. So let me ask you a question. If you are going at a constant speed, the velocity of your car is not changing. Then in first minute, let us say you have covered 20 meter. In the next 1 minute, you will cover the same 20 meter or more or less.
Same 20 minutes.
What is your opinion?
more
It will cover more distance.
You are traveling
yes
at same speed. Remember, the speed did not increase. So within the given time limit, if I say that in 1 minute you have covered 20 meter, in the next 1 minute, will you be able to cover 20 meter more or less? More than 20 meter or less than 20 meter?
No, I guess it will be same only now.
same 20 meter.
Because if you
same but distance beshi.
Okay, so let me clear it up. If you are walking with the same speed, in the first 1 hour, if you walk 2 kilometers, then if you continue walking in the same speed, then what will happen? In the next 1 hour, you will again cover 2 kilometers only. So it goes like that. Okay, that is why the line here is going to be like this. It will be a straight line. In first 1 minute, if you cover, let us say 2 meter distance, then after 2 minutes, you will cover 4 meter distance. So when it is proportional relation, see the time has become double and the distance has also become double. That is the uniform velocity, right? The line will be like this. Now, what about the velocity versus time graph? We said that the velocity is uniform. The velocity is not increasing or neither decreasing. The velocity is same. So then it will be like this. Okay, with time the velocity will not increase, not decrease, it will remain the same. Okay, so এরকম কয়েকটা পার্টকে একসাথে করে আমরা যখন একটা গ্রাফ করব তখন প্রত্যেকটা পার্টের জন্য তোমার বুঝতে হবে যে in this part whether the velocity is uniform or there is acceleration. Okay, so এগুলো একটু বোঝার চেষ্টা করতে হবে. So this is the second condition when we will see that the velocity versus time graph is like this, a straight line that is parallel to x-axis. We will say that the body is having a uniform velocity. And for uniform velocity, let me tell you or remind you, we use this equation, if you remember, s equal to vt. Okay, now let us take a look at the second condition. Sorry, third condition. This is the second condition, right? Okay, so moving with uniform acceleration. And whenever there will be acceleration, the distance versus time graph will be something like this. It will be a curve, not a straight line. Now, why it is so? Because whenever there is acceleration, what does it mean? The velocity is uniform or non-uniform?
Non-uniform.
Very good. Whenever there is change of velocity, then only there is acceleration. So uniform acceleration means non-uniform velocity. So that time what will happen? As there is acceleration, definitely you are accelerating. Okay, you are pressing the accelerator of the car, so the velocity is increasing. Now let me ask you, if I tell you that you have covered 20-meter distance in first minute, in 1 minute, then in the next 1 minute, if your velocity has increased now, will you cover more distance in the next 1 minute or less?
More distance.
More distance.
You are going at a higher speed now. So আগে স্পিড কম ছিল দেখে 1 মিনিটে তুমি 20 মিটার কভার করছো, বাট এখন যেহেতু তোমার স্পিড বেড়ে গেছে, you will cover more distance, right? যেহেতু স্পিড বেশি, within the same 1 minute you can cover more distance now. That is what it shows. প্রথমে যখন টাইম ইনক্রিজ হচ্ছিল, তোমার এই যে কি বলেন, distance and increase, it was not much, but later when your speed increased, you can see that the for a little bit amount of change in time, there is a lot change in the distance. Okay, so it will be like this. Then if we take a look at the velocity versus time graph for uniform acceleration, it will be like this. Okay, actually we should be mainly focusing on the velocity versus time graph because you are going to solve problem regarding to this. Okay, velocity versus time graph, this is important for MCQ, for different condition, how the distance versus time graph looks like. Okay, so kindly keep it in your mind. Okay, and try to understand more what is going to happen in velocity versus time graph. As we said, uniform acceleration, that means the rate of increase of velocity is uniform, right? Okay, in the first 1 minute the velocity increase, there is a certain amount. In the next 1 minute the amount will be same. Okay, that is the case with uniform acceleration due to gravity. When the body is falling, in 1 second the velocity increases by 9.8. In the next 1 second again it is 9.8. In next 1 second again it is 9.8. Every second the velocity increases by 9.8, 9.8, 9.8. So the rate of increase of velocity, it is uniform. That is why we say that it is uniform acceleration. Those who remember the classes that I took on uniform acceleration or have been revising those regularly, it is very easy for them to understand. Okay, so if anyone is finding any difficulty to understand these graphs, kindly go through whatever we discussed in velocity and acceleration in this topic earlier. Okay, go through the earlier lectures, that will make you easy to understand. Okay, so please remember, whenever we have a curve like this in velocity versus time, we can say that it is going through an uniform acceleration. Okay, remember. And then let me tell you, if the curve is like this, then you can say that the velocity is uniform. Can you tell me, if the graph comes back like this, what does this mean?
Deceleration.
Very good. Who answered that?
Alif.
Alif, excellent, excellent. This is deceleration. This is acceleration, the velocity increasing. Here the velocity is neither increasing nor decreasing, so uniform velocity, and here the velocity is decreasing, right? So when the velocity decreases, we call it negative acceleration, also named as deceleration or retardation. Can you tell me what will be the final velocity?
0.
Very good.
Zero.
It will be 0. It started from 0, it accelerated for some time, and then it ran with uniform velocity, and then it started decelerating, and finally the velocity became 0. That means the body became static. This looks like a journey, right? At first the velocity was 0. You started the car, you accelerated, and then for some time you went with uniform velocity, and then when you came near to your destination, you pressed the brake and your velocity dropped down to 0 when you reached your destination. Okay, so these type of graphs are the graph that you are going to see mostly. Okay, this type of graph, velocity versus time graph of this shape. So understanding every part is very much important, okay, because if you understand that this part represents uniform acceleration, then you will know that which 4 equations are there that can be used to calculate for the calculation of this part. And in the second part, as it is uniform velocity, you know which equation to use, s equal to vt. And here it is deceleration. For acceleration and deceleration we can use the same equations, but the difference will be acceleration will be positive here and acceleration will be negative here because the velocity is decreasing. I hope this is clear. Okay, now this has given you a shallow idea, not a very clear idea. I know this is, you are going to get a much clearer idea when we solve couple of problems. Okay, and the problem that we are going to solve, that type of creative are most likely to come in the board exam. For previous couple of years I have been seeing this. Okay, the question that comes from motion is mostly related to graph. Okay, so try to understand these graphs properly. A table will be given, some data will be given, and from that data you have to draw the graph, and from the graph you have to calculate, let us say, the covered distance, or maybe they will ask you to calculate the acceleration for each part. Inshallah we will see. Okay, I will forward you some, what does it say, creative picture. Okay, picture of some creatives, and when we solve it, inshallah you will have a clear idea, and with that we will have come to an end of the chapter motion. Okay. Okay, give me just 1 minute, I will send you picture right now. Okay, so I have given the picture of this question in WhatsApp for you, and I have also written the table here so that it becomes easier for me to explain. Okay, so as you can see, the time is increasing, right? 10 second, 10 second, 10 second gap. What is the increase in velocity for this 10-second gap? How much did it increase?
2
2
meter.
meter per second.
2 meter per second.
In the next 10 seconds, how much it increased?
2 meter per second.
2 meter per second. Same.
And that is the case throughout the process, right? Throughout the journey, that is the process.
Yes.
So what can I say? Is the velocity uniform?
Yes.
Yes, we can say it.
Carefully listen to the question. Is the velocity uniform?
No.
No.
No, sorry.
Listen carefully.
Acceleration.
Mute yourself, I will explain. The velocity, is it same? No. The velocity is changing. It was 0, then it became 2, it became 4, it is changing. So non-uniform velocity. But what is uniform? The acceleration, the rate of change of velocity, the rate at which the velocity is changing. In this 10 second, it changed to, in the next 10 second, again it changed to. So acceleration for first 10 second, it was 2. In the next 10 second, it is again 2. So throughout the process, you can see that it is 2, 2, 2, 2. So the acceleration, that is the rate of change of velocity, the rate of change of velocity. The velocity is changing, but at what rate it is changing? 2, 2, 2, 2. So we can say that it is uniform acceleration. Now we already know that if it is uniform acceleration, a little bit ago, we got to know that the graph is supposed to look like something like this, the velocity versus time graph. Okay, Now we will do we will put these values in velocity versus time graph, and we will see whether it is true or not, whether we get a straight line or not. As I don't have a proper graph on the board here, I would like to request you to take a graph paper and put all the values. You will see you will get a straight line. Okay. If I put the values over here, it will be 0, 0. So first point is 0, 0. Second point is t 10. Okay. For 10, it is going to be here 2. For 20, it will be 4. Then for 30, it will be 6, and it will continue up to 70. Okay. So I did not put the, I'm not putting the future points, okay, because you get the idea. The points are going to be like this. Then after you have plotted the points in the graph paper, if you join them, you will get a straight line without a doubt if you have done it correctly, inshallah. Okay, so this is the graph. This type of problem, even though they did not tell you, or they are not telling you to draw the graph in the question, okay, they did not ask you to draw the graph, still it's better for you to draw it, because that will help you a lot. How? Inshallah, we will see in future classes, not today. Okay, now they told us calculate the distance traveled by the car after first 1 minute 10 seconds. Now 1 minute is 60 seconds plus 10 seconds, that is 70 seconds. That means they are telling us to calculate the distance for total 70 seconds. Now, this is the case of uniform velocity or uniform acceleration.
Uniform acceleration.
Excellent, very good. This is the case of uniform acceleration. So for such case, which equation we use to calculate the distance? We use one of these four.
As, oh yeah.
Equal to u plus at as equal to u plus b divided by 2 into t as equal to ut plus half at square, then b square equal to u square plus 2as. Okay, one of these four equation, inshallah, we are going to use to calculate the distance. Now, at first, let us list up what are the information known. Okay, we know what is the total amount of time, that is 70 seconds. Total amount of time is 70 seconds. Do we know the initial velocity from this table? Do we know the initial velocity? Definitely we know.
There is, yeah, is it 0?
When time is 0, that is the initial. The time is initiating, starting. That velocity is known as initial velocity. So we can write u equal to 0 meter per second. Okay, this is second. And do we know the final velocity? They told us to calculate the distance traveled in 70 seconds. So after 70 seconds, what is the velocity? Do we know?
14.
14 meter per second. So these are the available information. Based on this, we need to calculate s is equal to how much. Okay. Okay. So first equation is automatically cancelled. Why? Because we need to calculate s and this does not contain s. So rest three are under consideration. So we will check which one we can use. Let us take a look at the second equation. Okay, now second equation, as we need to calculate, so s I will circle and I will try to put tick mark on all other quantities like we did before. So we need to know u. U is known. Yes, u is known, so tick mark. We need to know v. V is known. Yes, v is known, so put tick mark. We need to know time t. T is known, so put tick mark. So as it appears, the second equation we can use. Why? Because all the quantities that are needed to use this equation are known. So let us use this equation and try to find out the distance traveled. So we will write, we know s is equal to u plus v divided by 2 into t. U is initial velocity 0, v is final velocity, that is 14, sorry. 14 divided by 2 into time is 70. So s is equal to 14 plus 0 is 14. 14 divided by 2 is 7. 7 into 70. 7 sevens are 14.
140.
So that will be the total distance covered in throughout the process. Did you understand?
So do we have to draw the
Yes, sir.
diagram
Huh?
exam? Do we have to draw the diagram and all the things in exam also?
It's better for you to draw. If they did not mention in the question that draw the graph, okay, they did not mention, then it is up to you. You have the liberty to draw and not to draw. But what I suggest always is to draw. Why? Inshallah, in the future classes, you will understand. This one was easy from the table itself we could solve. But there are some, data, such data will be given, in which case it will be easier if you draw the graph and then solve, then the process will be easier. I will show you both the ways. Like if you don't draw the graph and try to solve, how you have to solve, and if you draw the graph and then solve, how you have to solve. I will show you both the ways. Many people find the first way to be easier one, they follow the first one, and many find the second way to be easier one, they follow the second one. So I will leave it up to you. Okay, I will teach you the both ways inshallah, and you will choose which one to follow. Okay. No. Okay. So next in D, we have from the stem with the help of velocity time graph, explain the rate of change of velocity at the time of 30-second instant. See, they are telling you to calculate the rate of change of velocity. That means rate of change of velocity is
Acceleration.
excellent, acceleration. So they are telling us to calculate the acceleration. So how we can calculate the acceleration? They told us to calculate 30-second instant. 30 seconds. So how we can calculate? A is equal to, we know that V minus U by T. So for first 30 seconds, the time is 30 seconds. Within this 30 seconds, what is the initial velocity? It is still 0. What is the final velocity at 30 seconds? It is 6. So 6 by 30, it is 1 by 5 is equal to 0.2 meter per second square. Understood? Sometimes they will not tell you directly that calculate the acceleration. Rather, they will tell you calculate the rate of change of velocity. So you have to understand that you have to calculate the acceleration. And they will tell you for which point to take. And if they don't tell you which point to take, then you have the liberty to choose any point you want. Okay. Inshallah, we will talk about it in the future classes. We have, yes, less than 1 minute. Okay. So kindly revise whatever we discussed today. I have forwarded you 2 questions. One I have discussed, another one try to solve at home, inshallah. Okay. See you in the next class, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Before we end the class, anybody wants to ask any question? Nobody. Thank
Sir,
you.
I want to ask a question.
Yes.
Sir, like in the examination, they will provide us graph paper or we have to bring it?
They will provide you the graph paper. Definitely. If you need the graph paper, they will provide you, inshallah. In mathematics, statistics, they will provide you. In physics also, if you need, they will provide you, inshallah. Okay.
Okay, sir, inshallah.